Today we're going to learn about trig functions. So trig functions return a ratio of the sides of a right triangle given an angle measure. So the three most common trig functions are sine, cosine, and tangent. And so let's start out with sine. So sine is abbreviated S-I-N. Looks like sin, but it's pronounced sine. And here we write sine of theta, and theta is going to be our angle measure. So return a ratio of the sides of a right triangle given an angle. So here's our angle, and the ratio that we're going to return is the opposite side length divided by the hypotenuse side length. So sine of theta, sine of this angle, is going to equal opposite side length divided by hypotenuse side length. So that's sine of theta. Next is cosine, and cosine is abbreviated as cos. C-O-S. So C-O-S, cosine of theta, is going to equal our adjacent side length divided by our hypotenuse side length. So cosine of theta is adjacent divided by hypotenuse. Lastly, we have tangent, and tangent, abbreviated tan, of theta is going to equal the length of our opposite side divided by the length of our adjacent side. So opposite divided by adjacent. And you may notice that tangent of theta is also equal to sine of theta divided by cosine of theta. And that all works to how if you put this ratio over this ratio, the hypotenuse lengths will cancel each other out. And so those are the three that we're going to focus on today, the three basic ones. And so here are some common values for these functions with some common triangles that we already learned in geometry. So firstly, we have here the 30, 60, 90 degree triangle. And from this triangle, we know that if the side length of this is 1, then the side length of this is going to be 2, and the side length of this is going to be root 3. So we already have that from geometry, but now we can use these lengths to discover what these values of these trigonometric functions are. So let's start out with sine of 60 degrees. So to calculate this, we're going to start off at looking at this angle here, this 60 degree angle. Now we're going to look, let's see, sine of theta is opposite over hypotenuse. So we're going to look at the opposite angle, or the opposite side to this angle, which is square root of 3. And we're going to divide that by the hypotenuse length, which is 2. So we're going to get square root of 3 over 2. Next we have cosine of 60 degrees. So we're going to start here again, and we're going to look at the adjacent side, which is 1. And then we're going to divide 1 by the length of our hypotenuse, which is 2. So we're going to get 1/2. Lastly, we have tangent of 60 degrees, and for this we're going to take our opposite side divided by our adjacent side, and we're going to get simply the square root of 3. And we see that if we also take the sine of 60 divided by the cosine of 60, we will also get tangent of 60. So that works out nicely. Next we'll look at the 30 degree angle here. And so starting from our 30 degree angle, we're going to calculate the sine of 30 degrees. So we're going to look for our 30 degrees, and we're going to go straight across the triangle to find our opposite side. And that's going to be 1 divided by our hypotenuse. Sine is opposite over hypotenuse, so 2. And so sine of 30 degrees is 1/2. Next we have cosine of 30 degrees. We're going to look at 30 degrees once more, and we're going to go adjacent to this, we get root 3, and then we're going to divide that by 2. So we get square root of 3 divided by 2. Lastly, we have tangent of 30 degrees, and for this, we're going to look at the 30 degrees, move across from it for the opposite side. That's 1, divided by the adjacent side, which is root 3. And of course, if you wanted to, you could also rationalize this answer by multiplying everything by the square root of 3, and you'll get square root of 3 over 3, which is also an equivalent answer. Now let's move on to our 45, 45, 90 degree triangle. And we know that with this triangle, if this is 1 and this is 1, then this is going to be the square root of 2. And so now let's calculate these trigonometric functions using our 45 degree angle. So first, the sine of 45. Let's pick a 45 degree angle here, and we're going to go straight across the triangle to find our opposite, which is 1, and then we're going to divide that by the length of the hypotenuse, which is square root of 2, and we're going to get 1 over the square root of 2, or if we multiply each side of the fraction, each numerator and denominator, by the square root of 2, we're going to get square root of 2 divided by 2. So that's how we rationalize that fraction. Moving on to the cosine of 45 degrees, we're going to move adjacent to the 45 degree angle and get our 1. And then we're going to divide that by the hypotenuse again. So 1 over square root of 2, which we know is equal to square root of 2 divided by 2. Now we have tangent of 45. And so this one's pretty easy. We just need to take our opposite divided by our adjacent. So 1 divided by 1 would be 1. So this has been an introduction to the 3 trig functions that we use the most. And one cool thing that you can use to remember these functions and what they represent is SOHCAHTOA. And SOHCAHTOA means sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So that's how you remember those. SOHCAHTOA. It's very catchy. So that's it.